In this lesson, you will learn about scientific notation. Let's take a look at some notes and examples that better explain this concept. Scientific notation, if you look at its definition, it's simply an abbreviated form of a number written in the form c times 10 to the nth power. The c just stands for a number, then times 10 to a particular power. And we will look at how to specifically write a number as we go through these examples. So let's scroll down and let's look at some numbers, and I will show you how to write them in scientific notation. In these first two examples, it states that numbers that are larger than 1 have a positive exponent when written in scientific notation. So notice that in example A, the number 9,000 is larger than 1. In example B, the number 120,000 is also larger than 1. So when we express them in scientific notation, we want to make sure that their exponents are positive. Now to write it in scientific notation, 9,000, basically what we want to do is abbreviate it and make it shorter. Now I'm using small numbers for examples. Normally scientific notation is used when the numbers are extremely large and much easier to write in this abbreviated form of scientific notation. So we're using quite small numbers just to make sure you get the idea. So what we want to do is we want to basically move the decimal point in the number so that it's after the first digit that's not 0. So right now in the number 9,000, we do not see a decimal point, which means it's at the end. So we want to move that decimal point so it's after the first number in the entire problem. So it would be after the 9. So we're going to put 9 point. Now if there's not a number after that decimal point except 0, we'll just fill in 1 0. So 9.0. That's the C, because we talked about scientific notation looking like this. C times 10 to the nth power. So the C is the 9.0 times, so it's not an X, it's an actual time sign, 10. Then the N refers to the number of spaces the decimal was moved. So in this case, it was moved 1, 2, 3 spaces. So our exponent would be a positive 3. So that is the abbreviated form of 9,000, 9.0 times 10 to the third. That means if you move the decimal point 3 places to the right from where it is, it will turn back into 9,000. Let's take a look at the second number. Here's our decimal point. Here's where we want it to be. Again, you want it to be after that first number. So the question is, how many spaces would that decimal point have to move? It would have to move 1, 2, 3, 4, 5 spaces in order to get after the 1. So our C would be 1.2, because you will include any numbers after the decimal that are not the zeros. Then we'll put our time sign, and then we'll put 10 to the 5th power because the decimal was moved 5 places. And if we move the decimal back 5 places to the right, it would again become 120,000. So again, the important thing to remember is the exponent represents the number of places that decimal was moved in order to write the number in scientific notation. And then to understand that the exponent also tells you if you want to rewrite it back into the original number, that's how many places you'll move the decimal to the right. In the next two examples, notice the numbers are between 0 and 1. And when that's the case, the exponent will now be negative. So what we want to do is we can actually see the decimal in these problems. We want to move them after the first number that's not 0. So in this first problem, it would be after the 3. So our C would be 3.4. The exponent again would be how many places we had to move the decimal from here to here. And if you count, it would be 1, 2, 3, 4, 5, 6 places. However, because this number is smaller than 1 or between 0 and 1, we're going to write -6. That indicates that if we were to turn this form of scientific notation back into its original number, that this time you'd be moving the decimal to the left rather than the right to create that original number that's between 0 and 1. Okay, so the negative sign is very important, indicating to you which direction the decimal goes to get back to the original number. In problem B, we see the decimal and we want it to be after the 4. So we want to put 4.57 for the C times 10, and this will be to the negative, and then how many places was that decimal moved? It was moved 4 places. So it'd be 4.57 times 10 to the negative 4. So this is how you change a number into scientific notation. Now let's go backwards and look and see how we change a number from standard form, which is its original form. Change a number from scientific notation back into standard form. Here we see the definition of standard form in red, and it says this is another name for the original form of a number, like 200, 314,000, or 0.000056. So standard form is just the original form of the number. Now, if you're given a number in scientific notation, and you have to change it back into standard form, this is where remembering what I said at the beginning is important. It's the sign of the exponent, because it tells you the direction to move the decimal point so that you'll know if your original number was larger than 1 or between 0 and 1. So remember, if the exponent's positive, you're going to move the decimal to the right to create a number that's larger than 1. And you'll move it, in this case, 4 spaces. So if you have 3.1, you'll move it 4 spaces, and you'll fill in the remaining spaces with zeros. The decimal point will then be removed because it's now been moved to the end. So this number, the original number, is actually 31,000. And you can work backwards and double check it by rewriting 31,000 in scientific notation, and you would see that you would get 3.1 times 10 to the 4th. In problem B, we're going to move the decimal 6 places to the right. 1, 2, 3, 4, 5, 6. So again, we're not adding 6 zeros because we already have the 8 and the 7 taking up 2 of those places. So the decimal has been moved to the end. So if we were to fill in our commas, we would actually have 2,870,000 as our original number. Now let's take a look at 2 problems where the exponents are negative. Okay, recall that when the exponents are negative, now the original number needs to come out to a number that's between 0 and 1. To ensure this, you want to move the decimal to the left this time. So starting with 3.1, we want to move it 4 places to the left. 1, 2, 3, 4. This time you will actually put in the decimal because this number is between 0 and 1. So the decimal is no longer between the 3 and the 1, so you'll want to remove that in your final answer. Now in some cases you can put the 0 in the front, so 0.000031 is your original number. So you should only have 1 decimal point in your final answer. In problem B, you'll want to move the decimal 6 places. 1, 2, 3, 4, 5, 6, which means you're going to add 5 zeros. So this decimal is gone. So you can put a 0 in front if you'd like, but it'd be 5 zeros after the decimal, and then an 8 and a 7. And that completes the lesson on writing a number in scientific notation.